All right. You guys see my screen?
Yeah,
Can you guys
yeah.
see my? Okay, awesome. All right, welcome to another session of where we learn how to code Bitcoin smart contracts, specifically using Script TS library. So previously we talked about the whole workflow. We show you how to code a contract. We show you how to test it, and then if there's something wrong, some bug when you are testing, how do you use Visual Studio Code to debug it? So hopefully, if you've not tried yet, so get some examples, walk through the examples. And today I'm going to go to the next, natural phase. Now you have the contract supposed to be ready, and how do I actually, you know, send it to the Bitcoin network? So that's how we going to show today. So basically, how do you deploy your contract, and then how do you interact with it? So before I even dive into that detail, so before we always talk about the contract, but almost in its isolation. We're not talking about the contract and what about how this contract is going to be represented. So here, just a brief reminder. So we have talked about the so-called UTXO model. So basically, you have a Bitcoin transaction, you have inputs and you have outputs. Oh, so in the output, you can think of it contains Bitcoin or or later on maybe you have some tokens or some other assets. So you use the contract to place a lock. Then when you are trying to spend it, use it in another transaction, you are going to provide a so-called unlocking script, which acts as a key. If this key can match this lock, then you are authorized to move it. So this is so-called UTXO model. So if you look at the context of a few more than one transactions, for example, here you have transaction A, B, C, and D. So transaction C, you can spend two outputs, one from transaction A, the other from B. So this you have the inputs, and then you can have multiple outputs, and then once you have created new outputs, you can be spent again by transaction D. So all the outputs, they are controlled by so-called, from later on we call it the contract or smart contract. And then the way you unlock it is to call any of its so-called public function from the input. So you do two things. So here, this is a high-level overview. Let's, to get this more precise, let's kind of zoom in to see what's in this input and what's in the output. So if you first look at the output, this is one example, right? This is a simple example. So output contains two parts. For example, output 0 here, you have the amount based on how many bitcoins in satoshis that's included in this output, and then the output part is a so-called you know traditionally called public key script because that's usually locked to a public key. But now we are more general, so you can think about this locking script. So basically, the lock. So in our case, it's just any smart contract here. And then in the input, so how do you spend this output? So you have to do two things. First one is, of course, is you're going to connect it, right? So which output we are spending. So, the transaction ID and then the identify this transaction and then the output index. So you can have multiple outputs. So which of the output, this input is spending. And then sequence number, I think we can ignore here in this case. And then the so-called traditionally called the signature script, but right now we call the generalized version called the unlocking script. So in this case, it corresponds to, when you call the smart contract here, the public function, what are the arguments you pass to this one? So that if this arguments, when evaluated on this public function, returns true, so that means this transaction, the key is correct, right? So this UTXO can be spent in this transaction inputs. So that's a basically a high level idea. So, look at the contract, how this contract fits in the context of Bitcoin transactions. So I'm going to pause a little bit here. Any questions so far?
maybe about this sequence number. So
Mhm.
what does it used for usually?
Oh, usually it's so-called for, think about almost like a version number, right? So think about if you have, let's say you have one output, you're now sending one transaction, try to spend it, but later on, for whatever reason, you decide to update, before it's mined, you decide to update this transaction in the mempool. So you can send another with a higher sequence number, and then the node will replace it. So think about like a version number. So if for sometimes, for example, in a most typically, right, in a payment channel, right, but if you have newer update spending the same UTXO, you can replace the existing pending transaction with a higher sequence number.
But usually what I heard in that situation, you just like run another transaction with higher fees, and the previous transaction with lower fees will be invalid because it will be mined later.
Okay, very good question. This holds almost true for all blockchains. So Bitcoin is the only exception, as far as I know. You cannot override previous transactions with a higher fee. You cannot so-called replace by fee. It's disabled. So let's say you spend this transaction, this UTXO send one transaction. Now you want to, before it's mined, you want to replace it. You post another transaction spending the same UTXO with a higher fee. The miner is going to reject it. You can even try this offline if you want. But this is a feature, actually, not a bug.
Okay, and this feature run both in BSV and BTC and BCH, or only in some Bitcoin versions?
Only in BSV. And this is a regional, right? Because you want to do a zero conf instant transaction. You could not have somebody paying for coffee and then leave and then 5 minutes later, before the merchant takes the money, he can just send another transaction, double spend pretty much, right? Just send the original UTXO to his own account, and then replace with a higher fee, replace the payment transaction. So that breaks the zero conf.
So this sequence number is unique for BSV, right?
You can think yes. They kind of like a retrospective, like a adaptive for some other use cases. But for us, this is only legit where you can replace transactions. That has not been mined yet.
Okay, so thanks.
Okay, good question. Okay, any other question? Okay, if not, let's get real. Okay, so I don't think I probably need to share this again, just so you can see my browser. Okay, can you see this? Now we switch gear. Can you see my browser?
Yes.
Okay, great. So we just talk about the high level, the overview, how the contract fits in the context of the Bitcoin transactions. So now, once we have that overview, we can go to the details. How do you deploy a contract, and then how do you interact with it? So deployment then is very simple, right? So basically, if you go back to the slides we just had, let me also bring it here. So if we just show here, right? So it's very simple conceptually. So you just put the locking script, right? You just compile the smart contract and put in the locking script of the output, right? And then you broadcast the big transaction that's inclusive. Make sense? So this is the high level, how you deploy one. Then how do you call one? Then you spin up, you create another transaction. You point the input to the output contains that contract, and then you give it the correct arguments. So that's how you call a contract, right? So this, you can read the details here, but basically that's what it looks like. So go to the more concrete. Let's, always we try to be hands-on. So let's look at a little bit of the code samples to see how this works. So first of all, because you have a contract is a class. So class, usually is kind of like an abstraction, right? It's a template For example, you can have a pay to script key hash contract, but this contract, you cannot just deploy it, right? Because you have different variables that has not been instantiated yet. So if you want to have a contract, for example, demo or pay to public key hash, whatnot, so you're going to instantiate it. Basically, you create an object out of it. We call, for example, here we call the new instance of this contract. So for example, right, in the pay to public hash, you have to give it the Bitcoin so-called address, which is the public hash, in the arguments. Or in the demo example, you should provide both the X and the Y value. So then you get a concrete object. So this is an object, a concrete instantiation of a contract. So once you have the contract instance, and then you can put it in a transaction. So you can look at here. This is some, we are using the so-called BSV, JavaScript or TypeScript library. So you can, for example, here, you can just say, hey, instance. I have the instance, contract instance. Now I can call dot login script, and then that's going to get its corresponding, login script, and then putting this output in this transaction. Is this clear?
Not exactly. So let I explain how I understand it, and probably wrong, and you will correct it. So
Yeah.
Scroll as a first step, a little bit scroll up to step 1.
Okay.
So when you instantiate a contract, so it's kind of like compiles from TypeScript to a script language, and then I don't know, something else happened or not. It's not entirely clear for me. And after that, when instance locking script is invoked, it's just like take some function from compiled contract and put it into the blockchain transaction, or not?
The second question, yes. So basically, now you have a transaction, right? Going back to our, the simple example here, right? So you have now you have the output, right? So you have the output, you have the satoshis, and then you have the login script here. So this is what's exactly happened here. So basically, you have the output, right? You can have probably a satoshi amount you put here, and then put in the login script part. You just put the contract script there. So in that sense, you put the contract in this output of this transaction. Is this how the different components fit together? Clear to you?
So you put here all the contract or some function from this contract with it?
Oh, the entire contract.
Entire contract.
For one contract, you can think of it as one entire login script. You cannot say a contract, you break it into multiple pieces and put into different outputs. That's not how the struct is structured. So one contract in one output.
And this contract needs to follow some interface to have functions with some conventional names, right?
Oh yeah, so that's how we, even in the first one. So basically, in our case, you have to extend the so-called smart contract base class.
Okay. And when you instantiate this contract, what actually happens when you instantiate it? So on the level, something like that.
Yeah, great question. So it actually, that's before you even instantiate, I think if we go through the test and debug session before. So before you do anything on a smart contract, you have to so-called compile it. So basically, this is what the name suggests. So this basically converts the TypeScript code into Bitcoin script. So before you do anything, always play with if you deal with any smart contract, you have to call this before you do anything else. So this is a compile. Okay, once you compile, you have the Bitcoin script there, and then that's what we call instantiate, right? So second step, basically you call this constructor. You just, this is a class, right? So you want to create an object so you can use it. So basically, call it constructor.
So object will be actually put it into the blockchain, correct?
Yes.
Okay, thanks.
Okay, good question. Yeah. Any other question? Okay. If not, let's go to, we just talk about how to deploy a contract, right? So first, before you do anything about a contract, you have to compile it. So after you compile, you can instantiate by call it, you pretty much call its constructor, get a new instance, right? And then you can put it in the output of a transaction. So after you have this transaction, you can then broadcast it, right? So that's how you deploy a contract. So after you have contract deployed, then you can, call it, interact with it. So the way you interact with it is called so-called public methods, right? So for example, we can come back here, this demo example, for all these methods, if it's declared as public, then you can call these methods in a transaction. So if you want to call it, again, it's also, let's go back to the conceptual diagram here. So when you're going to call it in the contract level, in the inputs, you put in so-called unlocking script. So unlocking script is just arguments to the public function you're calling. Okay, so in this example I show here, you can say you always call this get unlocking script. This is the function for any smart contract instance, and then inside it you can say, hey, this is the instance I call, one of its public methods. This is called customer entry. You can, in a demo example, you could call, let's say, add, right? So you can go to say instance dot add, and then give the correct argument. In that case, if you instantiate with x to be 1 and y to be 2, the sum is going to be 3, right? So you just call instance dot, add 3. So I think there's some more, I put the examples here, using the demo example, you can see here. So let's say I have a demo, as we have before, I have a few public methods. So you can say I even write the deploy contract here, the deploy method here. So you want to deploy it. So basically, you create a new transaction. This is how you create a new transaction. So you can put in the output. You can put the locking script there. You also specify how many satoshis you want to put it there. Again, this is so for anybody who is familiar with the UTXO set, this is how you can construct, a new transaction, right? You basically fetch the UTXO first, and then out of all this, you can create all the inputs. The inputs, you can specify all this UTXO set you are spending. And then you can add one input output with the contract locking script here. So after you have this transaction, the next step is always, once you have the transaction ready, now it's unsigned, right? So you can sign it and then broadcast it. Basically, we have a helper function. That's two things, as the name suggests. First, assign all the inputs, and then broadcast the transaction. So if everything goes right, then you can see this contract has been deployed. Any question here so far?
The sign and send, is that the thing that pops? Where's the private key coming from the wallet? Oh.
Yeah, great question. So there are two cases. One is we're just, getting some like a sample code, right? Just you are playing with it, what's going on under the hood. So here we put I'm going to show a demo later, but you can see we are simply put the private key in the source code because it's just a test. We're going to show you how does it work. So this actually just take this global variable called private key and use that to sign all the inputs and broadcast it. That's a case one, right? This is just only a demo. So in real production, you can imagine this thing is not going to be signed. Then you are going to request, to send a request to your wallet, and the wallet, after you authorize it, is going to sign the transaction for you, and then then broadcast it. Make sense?
Okay, thank you. Yep.
Okay.
Thanks.
Yeah. Good question. Yeah. One is for we're not just testing it and play with it. The other is in production. You're not going to write this private key here. You're going to request some API call to the wallet to sign it for you. Okay. Any other thing?
Is it just signing the SIG hash the same way as a normal Bitcoin transaction would?
Yes, because here, you are deploying it. So all the inputs they're coming from a regular pay-to-public key hash. There's no.
Okay, and that's bsv.js you're using there, yeah?
Yes.
Under the hood.
Yes.
And is that version 1.4 something?
Yes, we're now using 2.0. And the one big thing, so we added all the types into it. So now it's not only JavaScript, we added all the types. So it's like you can think about it as BSV 1.4 something plus all the types.
Yeah, okay.
Is that something that you've released, the 2.0? Have you forked it and created 2.0? Is that the actual?
Are you using 1.4 though, with types?
Yeah. Yes, we kind of like we didn't fork it because for the number one reason is because if we fork it, we have our version, and that's some users they're already using another version, so it's causing a lot of conflicts, right? Because in a big project, they may have two parts. One is to use us to deal with the contract. The other is they may import the old, the so-called canonical BSV library to create all the transactions and generate keys and whatnot. So they have different versions, then it causes a lot of conflict. So what we did is we didn't fork it, but we locally patch it. So inside the script TS contract, we still use the canonical version 1.4 or something, but then we made some patches inside our library. We didn't fork it. That's what we did before, but we find that caused some production issue when people are using two versions. It's confusing.
Okay.
But now the good thing is if you use our version, we kind of re-export the BSV, and it comes with all the types. Before it's only JavaScript, but now you can think about we kind of TypeScriptify it. So when you type in the ID, if you type, let's say, new BSV.transaction dot, it will give you all the type information for all the available methods you can call and all the types.
Yeah, I'm actually using 1.4 with my own types. Well, my own types, some types that I got from the internet, but they're not great actually. That's why I was asking. They're not great types. It's not got full coverage. So yeah, interesting. Thank you.
Okay, great. Yeah, we also got it from some other repo, but eventually it's not complete. So we kind of just focus on it and then add all the remaining types. So now it should be great. If you find anything missing, just always here. Just one thing. If you guys have any issues or suggestions, you can always click here. Provide open issue files. We'll fix it. And again, if you have PRs, that's even better. You can just click here. Yeah, give us feedback here. Okay.
Great. Thank you.
Thank you. Anything else? Anybody? Yeah, great questions. Keep them coming. Okay, if not, we just keep going. So we just showed how to deploy one, and then how to call one. Again, we also put this small wrapper here inside. So you can see you create another transaction. You just add the previous inputs. This deploy transaction, as you add an input. The input you're going to reference to the output. that of this previous transaction to spend from it. And then in the, as I said, in the input, you have the first one is so-called the out point, right? You spend which UTXO you are spending from, and then you set is the script, the so-called unlocking script. So this is how you do it. You get unlocking script, and then you just call the public function you want to call. So in our case, we are calling the function add with the z. So in this case, if z such that this all the assertions pass, this is going to correctly unlock. Otherwise, it's going to fail. So I'm going to stop, pause a little bit here, and anybody has a question about how do we unlock here? How do we spend or call the account in contract that is being deployed? It's good. Okay. Again, once you have the transaction, we can sign and broadcast it again. So if it's this the parameter is set up right, let's for example 3 here, because we are using 1 and 2, the 3 is the sum of these two. This is supposed to be if everything goes right, this is going to succeed. Okay. Any question? Okay. So if not, let's get hands-on a little bit more, and we look at this tutorial. This is going to be a full working code, full working example to walk you from, suppose you have already finished 1 to 3, and then you have the demo contract ready and it has been tested, and you have debugged, fixed all the bugs, and then we are ready to deploy. Here we just use example to deploy to the testnet, but the same thing applies, right? If you can switch just the API to broadcast, then you can broadcast to the actual mainnet as well. So here, just this is the test. So we use testnet example. So before anything else, if you run this for the first time, you're going to generate a new private key. Okay, so this is the code. You're going to generate the private key. We have the example here, but here just showing the high level. For anybody who has already using BSV library before, this should look familiar. It's 1.4 or X version. So basically, you call this to get a private key in testnet mode, and then you can even generate this testnet private key. You can derive its so-called address. So basically, what's under the hood is from private key, you can generate a public key, and then you take the public key, you hash it, and then you encode it to get the Bitcoin address. So if this is the first time you set it up, you need to get some test coins into this address. So you have some, you can pay the fees, right? Transaction fees. So you can get from our faucet or another of your favorite Bitcoin faucet, but you can get it from here. So once you have this ready, now you can proceed, kind of like go to what we had before. But first of all, you get a, private key and then fund it with some test coins. Is this clear? Okay. I assume if that's no problem, I assume that's good. So again, as I said before, this is pretty much kind of repeating what we had seen previously, right? So first, you have to compile it, and then you have to instantiate it. So here, just showing like a shortcut. You can compile it and then instantiate it. So some people like this Zen syntax. Somebody want to use await. Is whatever you prefer. Is all it should both work. So now after we have compiled and instantiated, we can go to the deploy. The deploy, again, I think I can break it down into 3 steps. The first one is you call some APIs to fetch all the UTXO, right? So that's how usually you construct the inputs for a new transaction. You get all the UTXO that's available. So you can, here we write a little bit of wrapper called, we call the UTXO manager. So basically this, if you give it its private key, it's going to manage all the current UTXO under this private key. So you can check out but it's a little bit wrapper, so you can get all the UTXOs. Pretty much we are calling some APIs. I think in this case, we are using tau APIs, under the hood. So we get all the UTXO belong to this private key. And then again, you have seen before, we have this non-contract function, get deployed transaction. We have the raw transaction, then we sign and broadcast it. Okay, then if everything good, this has been deployed. So this is, again, we have shown this before. So actually, let's go to okay, not yet. So this is a deploy. Again, is pretty much just a more concrete examples of what we have seen before using this specific, a demo example. But everything it follows from the generic deploy method we have seen before. Okay. So if you have, this is good. Let's go to the concrete example here. So again, this is the project we call script examples. So basically this contains a list of examples how to use script TS. So you can git clone it locally as what I had done before here. And then also, if you run the first step, you're going to need to provide your private key. So because I already set this up, already found some test coins. So this is good right now. So I'm going to run the deploy code. So here in source code, you have all the contract written. And then in test, we have two types of tests. One is so-called local test, is what we have shown before, how do you test it locally. And then we have a testnet test, basically how do you using the contract to deploy and then call its method. For example, here we have the demo. So basically here, it's doing a very simple kind of end-to-end integration test. So basically we deploy the demo contract and then we call from it. Right? This is just what we have shown in the documentation. So you get all the UTXO, you got the unsigned deploy transaction, then you can sign and send it. So if everything is great, you should see this contract has been deployed. We show its transaction ID here. And then again, if you want to call it, we have another function. We have a Libby wrapper before, as I have shown before. Let me put in here. So this is how you call the demo contract. Right? So basically, specify your spending from the deployed transaction, and then you set its script to be, using add method by calling its add method with the correct arguments here. So I hope this is everything is correct here. So if we want to see, let me run this test. So basically, if I run this, it's going to pretty much run this test. So if everything goes right, this test should succeed. So let's see. Let's run this test. And let's see how the demo god treat us today. Okay, no errors so far. It's compiling and deploy. Okay, good. Seems demo god is happy today. So it's got it deployed in this transaction, and then is being successfully called in another transaction. So once this is give us the transaction ID, now let's go to our favorite block explorer. Here I use what's on chain. So I testnet mode. So let's go to testnet. Going to search for this new transaction I just broadcast. Okay, seems is good here so far. So it's spending from this transaction the zeros output. So this is the deployment transaction. We can see it's deployed here in the first output. So in order to get a sense of what is being there, detail it cannot show here, we can click the scripts part, right? So if you look at the zeros output, this is what our contract looks like if in pure Bitcoin script, right? So basically this says I instantiate it with 1 and 2. So if we go back, because I just showed you the deployment and this is the calling transaction, right? So you can get a little bit sense here. This is still the deployment, sorry. Let's keep going, but let's search for it again. So if you go to script, you can see here, this is the 3 we provided in the unlocking script, right? So basically this is the Z there to unlock the zeros output from the deployment transaction. Okay, hopefully I've shown you the whole workflow. Any question so far regarding this?
I have a question actually. So I noticed there that you get a contract first of all, and you got a contract ID, and then straight away you called a method on the contract ID being deployed. So we don't need to wait for the contract to be made, right? Obviously.
No, in Bitcoin you can chain as many transactions as you want. You don't have to wait for it to mine.
Okay.
Yeah, it's like
okay.
You can spend the UTXO back to back. So you send transaction 1, and you spend it. You create a new UTXO, and then this UTXO can be immediately spent again. You don't have to wait. It's instant. You can do it. You can chain this as long as possible. I think before we have the 25 chaining transaction limits, but we got rid of it a long time ago. So for now, I think you can push thousands of you can change thousands of transactions in one go, and they will be accepted.
I can't remember the limit. There is still a limit. Is it 10,000?
Yeah, practical. Yeah, of course. It's like as always as a physical system, right? It's always a physical limit, but it's not set by the protocol. You can minus is kind of like a block size. I mean, in theory, you have unbounded limit size, but again, nobody has unbounded computers these days. So that's for all practical purposes, you can chain it as many as one. I think, yeah, as you said, maybe like 10,000 something. But that's more than enough. I couldn't imagine you have any kind of apps that needs to chain more than 10,000 within 1 second or something. Okay. Yeah, good observation. Anybody else? Okay, that means you guys all understand it now. That's great. So here I'm going to give leave another homework. Of course, if you have you have tried all these examples before, and then today, after this, before the next section, I strongly recommend you, or I command you, to try this example, to walk through the whole example. So you can deploy it, and then you can call it. So if you know everything is good, you can check it on what's on chain and see all the details. And because I want to, everybody play a little bit differently, so I have all your name list here. I'm going to later on send a, email. So basically, we have, previously when we are using AppScript directly, so we have this so-called boilerplate repo. We have a lot of examples. We have tens of or even 100 examples. I'm going to just because I want to everybody doing something slightly different. I'm going to assign each of you a specific contract in AppScript. So the idea is for you can manually convert this AppScript contract into the TypeScript contract. And then once you have that, you can walk through all these examples. And then if everything is good, you can see it on testnet. Or if you really want, you can switch a few parameters in the sample code, and then you can even deploy it to mainnet. Okay, this sounds good. Think about it as almost like a class project. Okay. Any questions? Okay. If not, I think that's how we're going to wrap it up today. So I hopefully showed you how to deploy and correctly contract, you can try this before the next class. And in the next one, I'm going to show you how do you add state into a contract, which is usually regarded as impossible for so-called UTXO model. So, if any concluding remarks? If not, I can hopefully see you all next week. Okay? All right.
Good.
All right. Sounds good. All right. Thank you. Thanks for coming. Okay. See you next time. Thank you. Bye-bye.
Thanks.
Thank you. Have a good one.